Hello everyone, welcome to Brain Blitz Audios. In today's episode of NEET Preparation, we'll be looking at previous year questions of physics in medical entrance examinations in India. Today we'll be dealing with the second chapter in the grade 11 syllabus of physics in CBSE, and the chapter that we'll be dealing with is motion in a straight line. Let's look at the first question of this episode. A particle is thrown vertically upwards with a velocity of 4 meters per second. The ratio of its accelerations after first second and second second of its motion is A2, B 9.8, C 1, D 4.9. So in order to solve this question, what we need to know is that the motion here is vertical motion. And in vertical motion, the acceleration and especially its magnitude of acceleration is always constant. So if the body is moving upward and at its first second, that value of acceleration will be g, and at its second or third second, the acceleration will still be g. So for the first second, it'll be 9.8. For the second, again, g will be equal to 9.8. And so the ratio of its accelerations, that is first acceleration divided by second acceleration, will be equal to 9.8 divided by 9.8, which will be equal to 1. And because of that, we can say that option C is the right option. The reason here is that in vertical motion, the acceleration due to gravity is constant as we move upward or downward. The only difference is in its direction. And over here, the particle is thrown vertically upwards, so the direction remains the same. And the magnitude of acceleration always remains the same, and it always acts downwards. So the acceleration will be same at both first second and second second. So on dividing the ratio, it'll be equal to 1:1. So first acceleration divided by second acceleration will be 9.8 by 9.8, which will be equal to 1. That is option C. Let's move on to our next question. A body is thrown vertically upwards with a velocity of 19.6 meters per second. We need to find the position of the body after 4 seconds. So A, it says it will be at the highest point. B, it will be at the midpoint of the line joining the starting point and the highest point. C, it'll be at the starting point, and D, none of the above. Now here we need to find out some values. So here the body is thrown vertically upwards with a velocity of 19.6 meters per second. So that means U will be equal to 19.6 meters per second. And over here, we need to find the position of the body after 4 seconds. So over here, first, we'll find out the time at which the object reaches its maximum position, that is the highest point. When does the object reaches the highest point? So in case 1, we'll assume v as 0 because at the highest point, the final velocity will be 0. And at all points, the acceleration will be same, and we'll take it as 9.8 meters per second square. And I'll come back to that. That's the reason why we took 9.8. So here we need to find time. So using the first equation of motion, that is v is equal to u plus at, let's plug in the values. It will be 0 is equal to u is 19.6. And since the body is thrown upward and g acts downward, it will be minus g. So minus 9.8 times t. So 9.8 t is equal to 19.6. T is equal to 19.6 divided by 9.8. So that'll be equal to 2 seconds. So this body with a velocity of 19.6 meters per second reaches its highest point at the time 2 seconds. And for vertical motion, the condition for time is like this. the time taken to reach maximum height is equal to the time taken to return to the ground from the maximum height. Since in this condition we do not consider air resistance, so no air resistance. So without air resistance, we know the condition that time taken to reach maximum height will be equal to time taken to return to the ground. So total time will be equal to time taken to reach maximum height, that is 2 seconds, plus time taken to return to the ground, which is equal to the time taken to reach maximum height. So that is again 2 seconds. So our total time is 4 seconds. So that means at 4 seconds, the object will return to its starting point. Since the upward motion is classified as motion in a straight line and it's a vertical motion, so once the object returns to the ground, it will be at its starting point. So option C, at the starting point, is the right option. So since the body reaches its maximum height after 2 seconds, after another 2 seconds, it reaches the ground. So it's like this, 2 seconds to go up, and then another 2 seconds to go down. So that means a total of 4 seconds. And after 4 seconds, it'll still be back on the ground. So it'll be at its starting point. So option C is the right option. Let's move on to our next question. Question number 3. The position x of a particle at any time t is given as xt is equal to 4t cubed minus 3t squared plus 2. The acceleration and velocity of the particle at any time t is equal to 2 seconds are respectively. We need to find out which of these is the correct option. How do you solve this question? All we're given is the equation x in terms of t as 4t cubed minus 3t squared plus 2. So here we have to use differentiation. Because we have an equation, we need to differentiate it in order to get the other values. Now, instantaneous velocity can be written as dx by dt. And since dx is given in terms of t, so since x is given in terms of t, what we can do is we can write dx by dt as d by dt of 4t cubed minus 3t squared plus 2. So on differentiating 4t cubed, we'll get 4 times 3t squared minus 3 times 2t plus 2 times 0, because the differential of a constant is 0. So that'll be 0. So 4 times 3t squared is 12t squared minus 6t. So this is the equation for velocity. And we also know that instantaneous acceleration can be written as dv by dt. So that'll be d by dt of the equation that we just got. So 12t minus 6. 12t squared minus 6t. And so on differentiation, we'll get 12 times 2t minus 6 times 1, because dt by dt will be equal to 1. So 12 times 2t is 24t minus 6 times 1 is 6. So this is the value of acceleration. So we have the equations for velocity and acceleration. Now we need to find out the value when t is equal to 2 seconds. So when t is equal to 2 seconds, our velocity will be equal to 12 times 2 squared minus 6 times 2. So that'll be 12 times 4 minus 12, that is 48 minus 12, which is equal to 36. So velocity will be equal to 36 meters per second. And acceleration, we can write that as 24 times 2 minus 6. So 24 times 2 is 48 minus 6. So acceleration will be equal to 42 meters per second square. So acceleration is 42 meters per second square. Velocity is 36 meters per second. And both these values are mentioned in option B. So that means option B is the correct option. In option C, the value of acceleration is wrong. And in the other options, both the values are incorrect. The right answer is option B, 42 meters per second square and 36 meters per second. And we did that by differentiating the equation given here and applying the value of t at 2 seconds. Now, let's move on to the next question. A stone is projected vertically up from the bottom of a water tank. So it is given the condition that assuming no water resistance, it will go up and down and come down at the same time. But if water drag is present, then the time it takes to go up, which is given as t up, and the time it takes to come down, that is t down, are related as. T up is greater than t down, t up is equal to t down, t up is less than t down, and option D is saying that we cannot predict. I'll write option D as incorrect because we do have an answer with which we can predict. Now, how do we visualize what is happening? So suppose this is the object, the stone, moving up. Now, when the stone is moving up, the water drag acts in the opposite direction. So the drag force acts opposite, that means down. You may also note that mg, the gravitational force, also acts downward. So in this scenario, F net will be equal to F drag plus mg. Now, what about the second case? So in the second case, the stone is coming down. So when the stone is coming down, the water drag acts in the opposite direction. So let's move back. So the drag is happening in the opposite direction. So when the stone is moving down, the drag is moving up. So the drag force acts upward. But mg will always act downwards because it's the weight, it's the weight of the object. So that acts downwards. So in this scenario, F net can be taken as mg minus F drag, since the object anyway moves down, so mg is larger than F drag. So for the first scenario, F net is the sum, and for the second scenario, F net is the difference between the forces. So F net in the first scenario will be m times the first acceleration, and F net in the second scenario is m times acceleration of the second scenario. Now, since we know that in the first case it is the sum of the forces, and in the second case it's the difference between the forces, we can safely conclude that ma1 will be larger than ma2. Means first force will be larger than the second force. So both m can be cancelled because over here it is the same that mass that's moving up and down. So a1 is greater than a2. Let's write acceleration as velocity divided by time. So let's say v1, v2, t1, and t2. So over here, we'll get the relation for time as 1 by t1 is greater than 1 by t2, which gives us the relation that t2 is greater than t1, or t1 is less than t2. Now here, t1 is considered as t up, and t2 is considered as t down. So the relation is t up is less than t down, because In the first case, acceleration is more. In the second case, acceleration is less. And since acceleration is inversely proportional to the time taken, we can conclude that the first time taken will be less than the second time taken. And that makes option C the right option. Option B is the case where no water resistance is present, so it's incorrect in this scenario. And option A, T up is greater than T down, happens when the opposite happens, so that is also incorrect. The right answer is option C, T up is less than T down, because due to the drag force, we have in the first time the force is greater, and in the second time the force is less, the net force. So we can get the net acceleration relation, and using the inverse proportionality with time, we got the relation T up is less than T down. Now, let's move on to the final question. A student is standing at a distance of 50 meters from a bus. As soon as the bus begins its motion with an acceleration of 1 meters per second square, the student starts running towards the bus with a uniform velocity u. Assuming the motion to be along a straight road, the minimum value of u so that the student is able to catch the bus is 8 meters per second, 5 meters per second, 12 meters per second, and 10 meters per second. So in order to get a gist of this question, it helps if you draw a diagram. Suppose that this dot is the student and he is away from a bus, and this distance is d, and that the value is given as 50 meters. And as soon as the bus starts moving, the student also starts moving, and at a distance which is s2 for the bus, the student covers a distance s1 and catches up with the bus. So the position of both the bus and the student is the same. Now let's consider the time for this motion to be t, and we know that d is equal to 50 meters, and the student is moving with a uniform velocity u. So u is the initial velocity, and the acceleration of the bus is equal to 1 meters per second square. So over here in this diagram, you can see that S1, the distance covered by the student, is a sum of the displacement between the student and the bus and the distance traveled by the bus. So if you have a bus far away, in order to catch up, you need to run faster than the bus. So you need to cover both the distance that was originally there, the displacement, and the distance traveled by the bus at the same time. So you have to run very fast. So using that scenario, we get to the relation that S1 will be equal to D plus S2. Now we need to find out the values of S1 and S2. So when the student is running, he's having a velocity u, and he's reaching the bus at a time t. So S1 can be written as u dot t, since distance is equal to speed into time. So S1 is equal to u times t. Now for the motion of the bus, for the bus, the initial velocity is 0, the acceleration is 1 meters per second. And we need to find, and we know the time is t. So over here, using the second equation of motion, we'll get S2 is equal to 0 times t plus half into 1 into t square. So S2 is equal to half t square. Now we'll put the values in the equation. S1 is equal to d plus S2. So that will be u times t is equal to d plus half t square. So over here, what we do is now we multiply 2 on both sides, the left-hand side and the right-hand side. So we get 2ut is equal to 2d plus 2 times half becomes 1, t squared. And so we can convert this into a quadratic equation by the formula t squared minus 2ut plus 2d is equal to 0. So this is according to the formula ax squared plus bx plus c equals 0. And in order to solve this quadratic equation, we need to solve using the quadratic formula. And what is this quadratic formula? We write it as x is equal to minus b plus minus root of b squared minus 4ac divided by 2a. And for our scenario, it's time that we need to calculate as the variable. So t will be equal to minus b. And here b is given as minus 2u. So that'll be minus of minus 2u plus or minus b squared is minus 2u the whole square minus 4 times a is 1 times c is 2d, and that is under a root divided by 2 times 1. So it'll be 2u plus or minus 4u squared minus 8d, that is inside a root, divided by 2. So now what we need to do is we need to take out something common inside the root. So that is 2u plus or minus 4 can be taken common, and then that'll be u squared minus 2d, and this is inside a root divided by 2. And since root of 4 is 2, we can write 2u plus or minus 2 times u squared minus 2d, and u squared minus 2d is inside a root divided by 2. Again, both of these are having a common term, so we take 2 outside, so it'll be u plus or minus root of u squared minus 2d, and then whole divided by 2, so that we get time as u plus or minus u squared minus 2d. So now what we need to do is we need to put in a condition for the quadratic formula. So for real value of time t, we have this condition that for a real root, we need to ensure that the discriminant b squared minus 4ac should be greater than or equal to 0. So over here, the discriminant is u squared minus 2d is greater than or equal to 0. So that means u squared is greater than or equal to 2d. So therefore, u is greater than or equal to root of 2d. And we know the value of d as 50 meters. So here we apply it. So that will be u is greater than or equal to 2 times 50, the whole root. So u is greater than or equal to root of 100. So we can say that u must be greater than or equal to 10 meters per second. So therefore, we need to ensure that the minimum value of u must be equal to 10 meters per second. So the minimum value of u is option D, 10 meters per second. So we first found out a quadratic equation which covers the scenario, and then we use the quadratic formula in order to find that out. And on finding u is greater than or equal to 10 meters per second, we can safely conclude that the minimum value must be 10 meters per second. So that ends this episode of NEET preparation. The chapter motion in a straight line is very important and it has a lot of questions. And so we've uploaded a couple of other episodes of the chapter motion in a straight line. You can access the links in the description down below. Now, for more of our useful and interesting content, don't forget to subscribe to our channel, Brain Blitz Audios, and we have a lot of educational content such as learn words, mind maps, memory hacks, etc. And for more NEET preparation, stay tuned by hitting that notifications button down below. So until the next episode of NEET preparation, take care, stay safe, bye bye for now.